each collected 6 trophies, and the masses of the trophies are shown in the table above. The mean of the masses of the trophies Meg collected is 0.1 kilograms, greater than the mean of the masses of the trophies Bob collected. What is the value of X? Okay, so since the mean of a set of numbers can be found by what? The mean is equal to basically the sum of the numbers in the data set over basically the number of values. Right, that's how we can find the mean. So we know that the mean of the masses of the trophies Meg collected, right? So mean Meg is 0.1 kilograms greater than the mean of the masses that Bob collected, right? So we can figure out what basically X is here if we know the mean of Meg, right? Of Meg's trophies, basically. So how do we figure that out? Well, first we have to figure and solve for this, right? So if we can find out what the mean of Bob's trophies are, then we can figure out what the mean of Meg's trophies are, and then eventually solve for X. So let's look at Bob. How can we figure out what the mean of Bob's trophies are? Well, we would take the sum of all these numbers here and then divide it by 6 trophies, right? There's 6 values. So we basically do 2.4 plus 2.5 plus 3.6 plus 3.1 plus 2.5 plus 2.7 and divide that by 6. So this gives us 2.8. So the mean of Bob's trophies is 2.8. So therefore, 0.1 plus 2.8 is equal to 2.9, which tells us that Meg's mean is 2.9. Okay, that's great. So how can we use this to solve for X? Well, how would we figure out what the mean of Meg's trophies were regularly? We'd do the same thing, right? The mean would be equal to the sum of the weights, of Meg's weights, over the number of values. Well, we know what the mean is, right? We just found it. It's 2.9. So 2.9 is equal to X plus 3.1 plus 2.7 plus 2.9 plus 3.3 plus 2.8 over 6 values, right? So to solve for this, we'd multiply both sides by 6. So this would become 6 times 2.9, which would basically just become 17.4 is equal to X plus 14.8. If you subtract 14.8 from both sides, you're going to get X is equal to 2.6.